In our next video, we are going to be using trigonometry, specifically the sine ratio, to determine areas of triangles. In this video, we are going to cover one CCRSM standard, and that is SRT 9. To derive the formula, the area is 1/2 A times B times the sine of C for the area of a triangle by drawing an auxiliary line from a vertex perpendicular to the opposite side. Let's get started. Today we're in lesson 31 of Engage New York, and as always you should have your student materials in front of you, and you should be writing in your student materials as we're going through this. Now in this lesson we are finding areas of triangles, which you've been doing probably since elementary school, and I'm hoping that you are familiar with the area of a triangle is not base times height, okay? It's only for rectangles and parallelograms, it's base times height. For triangles, which are half of a rectangle, if you think about it as half of a rectangle, it's 1/2 base times height. And that's stuff you should be familiar with. So on this left problem, if you think about the 5 as the base and the 12 as the height, then you could think about the area is 1/2 the base times height, or 1/2 of 5 times 12, which is 60, and we have no units, so it's just 60. Okay, now that should be pretty familiar to you as far as finding that base times height. Now the next one, a little trickier but not that hard because you're only given 2 lengths. They are perpendicular, which is super important because the base and the height must be perpendicular. So we have the area is 1/2 base times height. You think about this as the base and the height is perpendicular to it. So you have 1/2 of 20 times 8, which is 80. Now on this right one, we are given this length is 15 and this length is 12, and we are kind of stuck with figuring out base times height because we don't know what the height is, because the base and the height must be perpendicular. So I'm kind of stuck here not knowing what the height is. Now, are there things we could do to find the height? Well, if I knew, this angle down here, then I could use sine, cosine, or tangent to figure out what that height is. And in this lesson, we're talking about using trigonometry, using an angle down here to figure out what the height is, or more specifically, to what the area of this triangle is. Let me show that to you using this diagram down here in example 1. Now I'm going to use the image right here in example 1 to explain and derive the formula to find the area of a triangle using any 2 lengths and the angle in between them. Okay. Now, the truth be told, I only need 2 of these lengths. I don't need all 3. And I could use any 2 of them, but just because in the last image we had the 12 and the 15, I'm going to forget about the 7 right now. I don't really need that number. And I'll explain why as we go through this. Okay. Now, the area of a triangle is 1/2 base times height. Now we think about this as the base and this as the height. Okay. This length we don't really have a variable for yet. I'm going to call it A for now. And I'm going to do most of this work in terms of variables so that when I'm done, I will have a formula to plug things into in the future. Okay. Now, the base of this triangle is 15, but for right now, I'll just call it B. And the height is h, and I don't know what h is, but I'm going to do something tricky here. I'm going to multiply this times the number 1. And if you multiply by the number 1, then the value won't change. Okay, so I'm going to call this 1, a divided by a. And as long as a isn't 0, then that will not change the value of the area here. But because multiplication is commutative, okay, it's commutative, meaning 2 times 3 is 6, and 3 times 2 is 6, meaning it doesn't matter the order that you multiply things in, you'll get the same number either way. So using that property, I can switch this h and this a, the order of that, without changing the value of the area. So I have 1/2 b times a times h over a. Now the reason I did that is because this fraction h over a it's going to be like a trigonometric ratio. Okay, we've talked before about SOHCAHTOA, or sine, cosine, and tangent, and our angle we'll look at is the angle in between the two lengths we have, that angle right there. Now, because this is a right triangle right here, using theta as my angle of reference, then A is not the adjacent. It is the longest side of the right triangle. It's across from the 90-degree angle, and so this is the hypotenuse of the red right triangle. And H is on the opposite side from theta, and so this is the opposite. And the ratio that's most useful to me right now with the opposite and the hypotenuse is the sine ratio. So the sine of theta is equal to the opposite over the hypotenuse, which is h over a, which I'm hoping sounds familiar because we were dealing with h over a. And so I can substitute the sine of theta in right here, and I get 1/2 b times a times the sine of theta. And because we like to write things in alphabetical order, I will switch the a and the b using the commutative property of multiplication and get 1/2 ab sine of theta, which is equal to the area of a triangle. And the power of this formula is the fact that I can find the area of any triangle, whether it's a right angle or an obtuse triangle or an acute triangle, any triangle, as long as I know two lengths and the angle in between them. Here's an example of using that formula and that idea in exercise 1. A real estate developer and her surveyor are searching for their next piece of land to build on. They each estimate a plot of land in the shape of triangle ABC. The real estate developer measures the length of AB and AC and finds them both to be approximately 4,000 feet, and the included angle has a measure of approximately 50 degrees. So here's a quick sketch of what that might look like, which is all you need for the area formula that we were dealing with. So the area I know is 1/2 a times b sine of theta, the angle in between them. So it's 1/2 of 4,000 times 4,000 times the angle in between them, the sine of the angle in between them, the sine of 50 degrees. And we get 6,128,355.545, which, is very exact. It is an estimate. This is square feet, or I'll say approximately 6.1 million square feet, because it is an approximation to begin with. Okay, so that's how you figure out the area of a triangle using 1/2 AB sine theta, or two lengths, and the angle in between them. This video is about using trigonometry to determine area of triangles using two lengths and the angle in between them. Thank you for watching.